In this video, we are going to look at the ball valve, and I'm going to explain to you how the ball valve works and some of its main components. And at the end of the video, we're going to look at the advantages and disadvantages associated with this type of valve. By the end of it, you should get a feeling of where we can use the valve and in what sort of applications. So let's first pause the animation for a moment and we'll do a little spin. We can see the ball valve on this side, we can see the body. Notice that the body is slightly larger here. This is because this is where our ball is housed. If we go around here, you can see through the valve, and there we go, we're back round to the cross section side. I'll take a full view and we can have a look again, and it's symmetrical on the opposite side. So it's got quite a unique shape, but in order to fully understand the valve and how it works, let's just take the cross section. And I'll add the labels, although we're not going to talk in great detail about that right now. We'll do that later in the course. So here we have the ball valve with some of the main components labelled. The ball valve gets its name from the type of disc it employs, which is the ball. That is this item here. And we can see now that the ball valve is in the fully open position. We can see directly through the valve. If we press the play button, the animation now will close the valve, and what we've effectively done is stop the flow. Notice that we only turn the valve 90 degrees. So this type of valve belongs to our quarter turn or 90-degree rotation valve family. Other valves that are quarter turn would include the plug valve and the butterfly valve. As with all quarter turn valves, they are quite quick to operate. You can install a gearbox on the top, a planetary type gearbox, although this means that you'll slow down the actuation speed of the valve, or what they refer to as the response time. As you can see, the disc is manufactured of a metal material, looks to be stainless steel, as is the body itself. The seat is manufactured from a softer material, and this is going to be perhaps Teflon or some type of elastomeric material, perhaps neoprene or a stiff rubbery type of material. This allows us to press the disc in tight against the seat and we get a really good seal. We can see on top of the ball valve that the stem is connected to the ball valve in what looks to be a little ridge. What I'll do, I'll actually just get rid of some of these parts so we can see what is happening, such as the body. Okay, so now we can see that the stem connects, and get rid of the labels as well. The stem connects into the top or in this groove on top of the ball, and that's what allows us to rotate the ball and open and close the valve. Notice that the shape is rectangular, and this allows us to apply a high amount of torque without deforming the top of the ball valve. When I talk about deforming or deformation, I mean rounding off the top of the ball valve. So we've got quite a large area for the stem to come into contact with the disc, so we don't run the risk of rounding the top of the ball valve, which would mean then that we can't turn the ball anymore. There are three different types of ball valve. These are the Venturi, reduced and full bore. With a full bore, the ball itself will have a flow passage going through it that matches the internal diameter of the piping to which it's connected. And this leads us on to some of the advantages and disadvantages of the ball valve. The ball valve itself, because it can open up to allow complete flow through the valve, has a very low pressure drop. That means the flow is almost unrestricted through the valve. That is one big advantage. Another advantage is that the valve can be actuated very quickly. It only requires a quarter of a turn. The ball valve itself is relatively cheap and has low maintenance costs. It requires no lubrication, and one of the final advantages is that the ball seals very well against the seat, and this reduces the likelihood of leakage. The disadvantage with the ball valve is simply that it is very poor at throttling. In this respect, it's very similar to the gate valve. If we were to throttle the flow through the valve, then what we end up with is a very high velocity flow between the gap between the disc and the seat when it's in the throttle position, and this high velocity of flow could potentially damage the disc or the seat, and the valve will no longer seat correctly. So that is the big disadvantage with the ball valve. It is simply that you can only use it for on-off applications and not for throttling flow. As I mentioned previously, the seat that is used will often be constructed of elastomeric materials, or perhaps some form of rubber, neoprene, Teflon, etc. This material is a lot softer than the disc itself, which is good because it allows us to seat the disc within the seat very well. But unfortunately, it means we cannot use the valve for high temperature applications. If we do use the valve for high temperature applications, we will heat up the seat, and the seat will become quite hard, and we will end up with what we refer to as plastic deformation. Once we have a plastic deformation, it means that the shape that the seat is in will no longer return to the shape that it was previously. And if this occurs, then what we'll have is leakage between the disc and the seat, and the valve will pass and allow flow through the valve. So that's a big disadvantage with this type of valve. It's not normally suitable for high temperature applications. So that is how a ball valve works. We've looked at the advantages and disadvantages. You have a rough idea that you can use this valve for on-off applications, not so much for high temperature applications, and definitely not for throttling applications.